So Abbas has been talking to us about measurement tools, okay? And I'll just tell you a small story about measurement tools. If you use the wrong tools, you get the wrong results. This farmer was lying by the roadside next to his camel, and this driver pulls up by the side of the road and said, "Farmer, do you know what the time is?" The farmer kicks his camel. The camel moves, and the farmer said, "It is 10 o'clock." And the driver went away. Coming back again, the driver stops by the farmer and says, "Farmer, do you know what the time is?" The farmer kicks the camel again. The camel moves, and the farmer said, "It is 5 o'clock." And the driver said, "Amazing. You can tell the time accurately by kicking the camel. And then the camel moves, and you can tell me what the time is. How did you do that?" Say, "It's not a big technology. The camel is actually blocking my view to the church clock. When I kick it, it moves. I can see the clock." So I will tell you what to kick on your network, and you can see the real bandwidth. Thank you very much for that presentation. Please, are you in a hurry?
No. I thought because you told me to do it quickly.
Yes, we have 2 more presentations. So after those presentations, then we take the questions. All right, so I'd like to call Juan now to give us his presentation. I am giving you 10 minutes. Okay. Thank you.
Hello everyone, this is John from CCSI, that means Chinacom Service International. And I'm very glad to have this chance to give a speech on AIS 2014, thanks to the organizers and especially for Djibouti Telecom. First of all, I want to ask, how do you think about the opening video you saw yesterday? Anyone? It's good? Yeah, because I'm the director of that. Yeah, thanks. And as what you saw in the video, an IDC project is planned for Djibouti Telecom, and that is one of the most popular business for telecom operators around the world. And as you know, China's largest, sorry, where's the, that's the movie, and that's the IDC you saw yesterday. And here, China's largest telecommunication market of the world, 3 telecommunication operators, that is China Mobile, China Telecom, and China Unicom. And they started to IDC projects from 2008. Now the government and enterprises also run some IDC projects, and some of those internet-relevant enterprises open the IDC service to the public. Now the slide shows a few typical IDC projects in China, and this one was in Indonesia. Okay, we'll start about the talk about the IDC. The topic will be in 4 chapters. One is the general introduction about IDC, 2, green IDC, 3, cloud IDC, and 4, smart IDC. This one, IDC, is short for Internet Data Center. It utilizes the existing internet communication lines and benchmark resources, establishing standard professional equipment environment. As you see, there are 5 steps for the IDC projects. First, that's the traditional IDC. Second, green, then cloud, then fast modular IDC, then the container IDC. That means like the storage things. Here, that's the principle of establishing the IDC. 3 points. 1, function, 2, the security things, 3, the power saving. Now we talk about the standard about the IDC, then that is tier 942. The standard is from the US. We compare those each level of tier standard. Now we use the tier 3 and tier 4 as an example. You can see the biggest difference between tier 3 and tier 4, that is backup. Tier 3 requires N+1 backup, and the tier 4 standard requires double N. That means more safety, more investment. So now the most common IDC, we use the T3 standards. Now I'm going to show you what we have in the IDC. We can separate into like 5 sections. One, that's the electricity system, such as generators, switch cabinets, and UPS. And second, that's the air conditioning system. That means the air conditioner and some pipes. 3, that's the fire extinguisher, because in the equipment room, it requires no water or no liquid can be in the equipment room, so we use the gas system in DC rooms. Then 4, that's the main equipment, means the racks and the servers. Then the other things, that's the monitor system. We need to monitoring how the system works. And that's who are using IDC. We can see that's ISP, ICPs, financial and assurance, technology and IT enterprises, logistics, hotels, and the government. We take Djibouti as an example. We have rich submarine resources and we have many POPs. First, we can use IDC to have the IDEC, that means International Data Exchange Center. And transportation is the largest industry for Djibouti. So we can use the IDC for logistics, and also the government want to have the e-government plan. The government need a very large data platform to support the planning. Then we'll talk about the green IDC. The green IDC, there are 4 points. The first 2, IDC is a high energy consuming building. And we need to reduce the energy consuming, make a low carbon environment and protect the natural. That means the social responsibility for operators, telecommunication operators. And those 2, reduce the operating cost and get more profit, and the competitive price can attract more clients. That's about the operating cost and how to earn more money for the operators or the owner of the IDC. Here we can say that green IDC can separate into three different directions. 1 is the green IT, 2 is green building, 3 that's the green infrastructures. The IT planning always comes first. It will give the next step, architecture design and energy design. We can see that the building itself and strict requirement. The customers, first of all, that's the customize the servers. Second, virtualize the server. 3, server racks. That means before we design the IDC building, we need to give them a very strict requirements. Now here, about the building itself, for 4 directions. 1 is saving the land, 2 saving the material, and 3, that's the water saving and the energy saving. For the energy saving, the most part is the electricity. Here we can say some general requirements for the IDC. The right part, that is the load for IDC, the capacity for each rack, the load for the ground, for the deck, and here that's for the cooling. And the cooling requirements, we can see that many parts like the mixed high-low density zone, etc. And we want to have one sentence more is the capacity of the racks is not according to the server. That is based on capacity of cooling. The racks full of server are like boilers. So as you all know, servers cannot run well in a very high temperature. So the cooling solution is the bottleneck for each racks. And here we're going to talk about how to judge if it's a good IDC or not. That's the PUE value. PUE is short for power usage efficiency That is from the US standard. It equals the total power load divided by IT equipment load. And lower is better. So now we have some solutions to control the POE value under 1.5. Now what we have to do for take down the POE value? First, that's the AC system, and second, that's the electricity. Gonna talk about later. For the AC system, we need some airflow organization. You can see from those flashes here. When we have the organization, we just put some tunnels and close the space between racks, and it's going to be much more better compared with one without any control. And here, that's some GIF pictures about how we arrange. And here we use some special software to simulation the environment of the IDC room, and then we can check where's the heat point. We just do some special cooling at that point. It saves a lot of energy. And here, that's the AC. That's the new technology about the AC. What I want to say more about that is the heat pipe. That is the latest technology for that. You can see those two. For each rack, the load just around 10 kilowatt for each rack. But when we use the heat pipe, it can be up to 20 kilowatt for racks. Now here, that's some solution about electricity and the UPS. And here we're going to talk about the modularize for the design of IDC. We use the standard modules in the IDC to make the same standard, and that saves a lot of energy. And now we talk about the cloud IDC. Cloud, which means we use the IaaS plus the traditional IDC. What is IaaS short for? That means infrastructure as a service. And PaaS, that's platform as a service. And SaaS, that means the software as a service. For now, at this moment, we can only have the infrastructure as a service. That means IaaS, but in next few years, we can make it to PaaS or SaaS. We just compare what's the difference between cloud IDC and the traditional IDC. Why we say that the cloud IDC, that is the next generation. The first line, that's the traditional IDC. We can say for the resource use, the use ratio is low because of the server cannot be used by only one client and a single business operation. For cloud IDC, we can improve the use rate by using the virtual technique to make one server transform to many servers. Second, investor return. The traditional IDC, that is low compared with the cloud IDC. The cloud IDC computing technique upgrade the ratio of resource use and management efficiency, reduce the cost of computing resource, energy consumption, and human resource. Third, the resource allocation for the traditional IDC is impossible because some enterprise want to add some capacity for their business. They need to rent a new rack or a new server. But for the cloud IDC, we can just move the resources such as storage or the bench wide, this kind of things. And here, that's the resource expanding. That's the similar like what I said before. Then that's the innovation of cloud IDC. The business operator module transformation from branding of resource to render computing capacity, rising the users viscosity and upgrade the add value of service. We changed from machine rooms, racks, and benchwise resource to rent to server, storage, network, and capacity of computing to rent. In the future, users don't need to buy any desktop or laptop in their office, even those OS and softwares. The only thing they need is a small internet box, a monitor, and internet with cloud service. It saves a lot of money for enterprises. Here we have a sample project that's in Inner Mongolia in China. And you can see that's 42 buildings around, around 100 hectares, and the investment is $2 billion US, and we have over 100,000 racks here, a lot. It takes half of the capacity of whole China. The park will be officially put into production in July 2013 with three-way power supply from 6 substations. In the future, it will become the 9th largest node of China Telecom's backbone network. Super 5-star premise adopt advanced green and energy-saving technologies. The park boosts data centers of most advanced design concepts, large scales, and highest security currently in China. Yes, that's it. And we have the smart solutions for cloud IDC, such as we have the computer communication system and smart card system, monitor systems, file linkage systems, and intelligent visitor systems. All of this can help us to manage the IDC very intelligently. Thanks a lot.
Thank you very much. I'll give the floor now to Zong to quickly make his presentation. 10 minutes too, please. Thank you.
So, hello everyone. I'm Zhong from CCSI, and my speech is Evolution of the Network Security. So in my topic, there are 3 parts. The first one is why discuss the network security. Successively, I will talk about the evolution of the network security, like the threats and the trend of the security. At the end is the new network security and technology. So first of all, why discuss the security system? And this year, the USA tells a story, Edward Snowden tells a story about network security and the National Security Agency. And I think everyone knows this guy. So in the old age, we can say that no information, no modernization. And now we should say no network security, no proliferation. So secondly, the threats and the trend of the security. So in this paragraph, we can say that the network security contains a lot of things, like the lowering the threshold for attack, the web security, and the user information disclosure, malware burst on the mobile internet, more DDoS attack, more ATP attack, more and more trusted systems become untrusted. So this is caused by the, in word we can say that it's caused by the the network itself, and because of the new technology, the big data, the mobile internet, the cloud computing, it takes more challenges about the security. So this one is from the old to the new. In the left, we can see the old integration, the intelligent, initiative, the unity, and the delicate. And for the new one, network security system, we have the confidential, the integration, the available, the identity, controllable, and the user behavior control. So let's pass to the last part, the new network security system and the technology. So first, let's see the classic network security architecture. So the whole structure consists by two parts, the network security management and the network security technology. In details, in the part of network security manager, we can see three things: network security organization, security policy, security support. And at the bottom, we can see the details. There are 1, 2, 3, 4, 5, 6 or 7 things. But this is not what we focus on. What we are interested in is the network security technology. As written in the PPT, we can say that there are 4 parts: the board protection, the internal protection, network infiltration, and support facilities. So past the classic, we can see the new one. The first edition, so we focus on this part, network security technology. First, we can say that what we add in this part is the terminal security. The network security technology consists of 5 domains, and for now, we have 1 more. So let's pass the next page. In board protection domain, there are 3 kinds: access control, intrusion detection, and prevention and abnormal flow protection. And secondly, in internal protection, there are 5 kinds: risk management, malicious code protection, audit, content security, and data security. So this is part 2. In network infiltration protection domain, there are 3 kinds: router security, DNS security, and web security. In supporting domain, there are 2: password and authentication. In the terminal domain, there are only 1: terminal security. So maybe the table is a little boring, and now we can pass a thing even worse than boring, the graph. This is a hypercircle of network security technology. According to the development of those technology, we can divide them into 5 categories, just showed in the end. In the bottom of the chart, we can see 5 things. According to the visibility of those technology, we mark this technology with different visibility levels. So next, we will talk about each one in detail. The first phase of the plateau is productivity. We can see so many familiar technologies. Yes, they all belong to the traditional technologies, such as firewall, PKI, IDS, IPS, SSO, and DDoS protection. All this technology focus on traditional domain of traditional networks. Most of them focus on the border protection. This technology work very well in the traditional environment, but not good at dealing with the new challenges, just the way I have said that a little before. And so such as cloud computing, mobile internet. So all this technology need a new change and new variant. All through the phase, we pass the phase 2. There are some technologies which have to deal with some problem. If successful, they will go up to road, but if not, they will head down road, even be abandoned. Such as BGP proposed by Cisco do not need to set up PKI system, but relied on VeriSign and other institutions to provide public key and signature. So with this, lack of trust security may be not high and has not been applied yet. So currently, this development phase is still in the lab. And then, at the peak of the inflated expectation, there are some technologies as solution under some tough challenges, makes new ways to solve some traditional problems. The malicious software can be detected by sandbox test technology. Therefore, the sandbox technology is regarded as one solution for zero-day malicious software, and it's currently in the development of overheating period. And the context-aware security technology is based on the context awareness, which has changed the traditional way of statistic authentication. Through the combination of context-aware and dynamic measure, context-aware security can provide adaptive authentication, realize users' seamless continuous verification in mobile application switch process, and at the same time to reduce the operating cost. This technology is the technology overheating period. ISA and other manufacturers have begun to offer the similar products. And with the developing of the cloud computing, visualization gateways important security tools to deal with the threats visualization layer. But there's more work for visualization to do to complete with the traditional security gateway. RPKI and the BGP-SAC is used to enhance the security and integrity for IP route. The RPKI and the BGP-SAC standard has been basically matured, deployed, application is gradually expanded, now in the technology development overheating period. So the last page, the technology, trigger fast, and there are some more technologies which are still in the fancy, need more attention to resource to grow up. The OAuth provides a user open source licensing standard, allow user to provide a token from the third party instead of the specific account and password to access. The OAuth solves the balance problem of user account security and authority, and so it gets on the up road of the technology trigger. OpenID Connect is the integration result of OpenID and OAuth. At present, it's still in the embryonic stage and has not formed a formal standard. The basic idea of Rover is to verify whether AS has announced a corresponding prefix authorized by reverse DNS queries. Rover needs support to DNSSEC. The technology is currently in IETF phase and the draft. Password, a DNA password, and use DNA as an information carrier. With modern biotechnology as the implementation tools, it has advantage of higher parallelism, higher storage density, and its security does not depend on the mathematical problem, but it is still in fancy and in the lab. Maybe we need more time to develop it. Thank you.
Thank you very much, Mr. Zhong. I now open the floor for questions. You are free to ask questions, but will you please permit me to limit the questions to just 8 minutes so that we can be out of here by exactly 1 p.m. for lunch. So it is your questions that are now going to stand between us and lunch. So let's go. Questions. Please, when you ask questions, limit it to 1 question and 1 participant, or 1 presenter, so that everybody can have a fair chance. All right? So if you want to ask questions, did I see a hand at the back there? Yes, thank you. You have the floor. Please just direct it to one of the presenters and then your questions.
My name is Matogoro Jabera from Tanzania. I'm directing my question to the one who presented on the bandwidth issues. We are seriously facing the bandwidth challenge in my university, and probably can you recommend some of the applications or software, especially open source, that I can use to optimize bandwidth in my university, as you have shared the experience on your project. Thank you.
Hi, nice to meet you. There are many tools to optimize the bandwidth, but it depends what you want to do. There are some tools. If you want to optimize the queue size of packets regarding bandwidth, there are no open source tools that are easy to use. It's better to use a solution from integrator like Alot or Juniper or Cisco. But now there is other thing that you need to think. There is one other important thing you need to think about bandwidth is the monitoring of bandwidth. If you are able to associate a net flow analyzer and some open source tools like Nagios, Cacti, and configure your own plugin regarding your requirements, you are able to monitor your bandwidth and to know where is the thinnest bottleneck, and then complain to your ISP in order to adapt. And by monitoring the error packets and the net flow analyzing process for your customers or your students, I think the best combination will be a tool called MTR, Nagios, and Cacti. With this monitoring tool, you will be able to choose the right ISP and then use efficiently at maybe a rate of 80 to 90% your purchased bandwidth.
Thank you very much. Just to add that you can also take a look at the training notes on the network management track, which held at the workshop here in Djibouti. So you see quite a lot of recommendations in that workshop. Yes, next question.
Thank you. I'm Sam Saleh from Sudan. We are excited about the presentation for today, the very high technology and well organization of the ICT infrastructure in different part of the world. However, I'm wondering, here in Africa, we are not manufacturers. We didn't make our ICT devices. So I'm wondering how AFNOC can push to adopt or implement technologies like software-defined networks or virtualization, clouding, how we can push to adopt those technologies to make our operators or our ISPs implement or design their own network devices, or maybe give them more facilities to adopt device especially to the local network. I think we are not like China or Korea. We cannot design or manufacture our device, so we can use SDR and SDN and other technologies to do that. Thank you.
It's for me?
Sorry, who is your question for?
It's not a question as such. I'm just throwing ideas. I don't need a reply on that, but just throwing ideas.
No, it's okay.
Okay. On behalf of the panel, thank you for throwing the idea. We catch it. All right. Any other question or idea? Yes.
My question is to Mr. Grumman. Please, what happened to IP version 5?
So I don't remember the specific application, but the version 5 number was used for something else within the IETF, and so it was skipped. It wasn't. It didn't have anything to do with what you would think of as IP. So it was just kind of skipped over.
I guess it would then be right to ask what happened to versions 1 to 3.
Versions 1, 2, and 3 were used in the like Vince Cerf and John Postel and Bob Kahn, all these guys, when they were originally doing TCP/IP. The first phases, the first iterations of the experiments in the lab were 1, 2, and 3. 4 was the one that happened to escape the lab, and then 5 was used for something else, and 6 is the future.
All right. Even if there are now questions, I would want to wield the big stick and say we have come to the end of this session. I'd like to thank the gentlemen who have made the presentation. First, I'd like to thank Chris very much. Thank you. Please, a round of applause for him. I'd like to also thank Abbas very much for his insightful presentation. One of the things about listening to technical people is that you don't really understand what they are saying until you get to need what they are saying. Then you're like, aha. Because the first time I sat in a session and a gentleman was presenting something about Google and how they want to revolutionize the search business, I was like, so what's the big deal about searching? I'm no more an illiterate now. I now know searching is big business and big money. So a round of applause for Abbas for his good presentation. When you need it, you will be calling him very soon. I'd also like to thank our friends from CCSI for that insightful presentation. Thank you very much for the good work you are doing. And thank you for that very nice movie on Djibouti. I hope you will be kind enough to do one for me on Nigeria. Thank you very much. So thank you all, ladies and gentlemen, for your attendance at this session, and see you all after lunch. Thank you. Thanks.